Hi, in this video I'm going to demonstrate how to use your calculator to find the mean and standard deviation of a discrete probability distribution. I'm going to go through two examples. So I've cleared 4 lists on my calculator, lists L1 through L4, and then I've pre-entered the data from the 2 examples I'm going to go through. I'll give you the opportunity to put the data into your own calculator as we go through each example. The first example I want to go through concerns Ishiro Suzuki's hit record for the 2004 baseball season. This is problem number 21 on page 295. You can see that what they've done is to tally the number of hits he got in each game that he played in 2004. Then what they did was to convert those tallies or frequencies into percentages. So you can see, for example, that in about 33.5% of the games he got 1 hit, and in about 2.5% of the games he got 5 hits. I'm going to refer to the second column as probabilities because you can use it to answer questions like, if I randomly select a game from 2004, what's the probability that in that game Suzuki got 4 or more hits? And then to answer that, you would simply add the probabilities for 4 and 5. So what we're going to do with this problem is to compute the mean and standard deviation of this probability distribution. Now the calculation of the mean is actually easy to do, so I want to encourage you to do this by hand a couple of times before switching over to the calculator. The reason is that it will help you to get a feel for the idea that if the value of the random variable x has a higher percentage or probability associated with it, then it's going to count for more when you calculate the mean. In other words, the probabilities are like weights, and the ones with greater weights will have greater influence on the mean. Now the calculation for standard deviation is a little more involved and takes a few more steps. It's shown here on page 292. In example 8, they've shown 2 methods where in each one you've got to set up a table and do several intermediate calculations to get to the final answer. What's important in studying this is to understand what quantities figure into the calculation and how they're handled. So if you look at the box on page 92 where it defines the variance for a discrete random variable, you can see in the first example that you've got to take the difference between each x value and the mean as part of the computation. You might recall doing something similar to this when you computed the standard deviation for a set of sample data. Let's go back to the first example. You can pause the video here to enter the number of hits, x, into L1 and the percentages or probabilities into L2 on your own calculator. Okay, so you can see in my list view here, I've got that data, x, in my L1 and the probabilities in L2. And I want to use the function 1VARStats to compute the mean and standard deviation for this probability distribution. So what I'm going to do is go to the Stat menu and then over to the Calc submenu, and then when I press Enter, it's going to put 1VARStats on my main window. Next, I need to give it 2 inputs. The first is the list containing the x data, so that's second L1, then comma, and then the list containing the probabilities, so that's second L2. Now when I press Enter, what you'll see on the first line is the mean of the probability distribution. So what that means in this case is that in 2004, Suzuki averaged 1.6 hits per game. Now a little further down, you'll see that the standard deviation sigma is about 1.2. So you've got your mean and standard deviation for this probability distribution. I want to point out a couple of other things to you. First, you'll note that the sample standard deviation is left blank, and also that the sample size is equal to 1. Now the sample size is computed simply by adding up the values in your probability list. Whenever you enter a valid probability distribution, of course, that's always going to be 1. Okay, so that's how we get n equal to 1. Now whenever that's the case, that n is equal to 1, the calculator is going to leave the sample standard deviation blank. Now in the second example I'm going to do, you'll see what happens with a slightly different situation. The second example I'm going to do is on page 295, and it's question number 23. In this example, what you have is the total number of games played in each World Series from 1923 to 2005. So it's organized by the number of games of each series from 4 to 7, and then the second column shows you how many times that occurred. Now you'll note that they've simply given you the tallies, or the number of times that the series were a particular length, without actually converting them to percentages like we had in the first example we went through. And in the instructions for this problem, you're asked to compute those percentages as your first step. What I want to show you in this example is how your calculator will do that automatically when computing the mean and standard deviation. So you can enter this data from this table as it is. You can pause the video here to enter the data. I put the number of games played, X, into L3, and the number of occurrences, or the frequency, into L4. So let me go into my list view to show you that. Stat and then enter puts me in the list view, and then if I arrow over to the right, you can see my L3 shows the number of games and L4 shows the frequency. Now I'm going to run one var stats in the same way I did the first example. So I'm going to go to stat and then over to calc again and then enter. Again, putting one var stats onto my main window. And next I want to give it my X values, which are in L3. So second L3 and then comma and then the frequencies with which those values occurred, so that second L4. Then I press enter and we can take a look at the results. We can see on the first line, X bar, is the average number of games played in a World Series, which is about 6 games. If we look at the standard deviations, we can see values given for both S sub x and sigma sub x, and they're actually kind of close in value. But the value we want for this probability distribution is sigma, and here's why. Your calculator computes sigma by first converting the frequency data in list L4 into percentages. Now you can see L4, the total number of World Series for this set of data is 82. So what that means is it would take each of these values in L4 and divide it by 82 to get a percentage. Okay, so once it does that, then it uses the formula for standard deviation that we saw on page 292, and that's the formula for computing the standard deviation for a discrete probability distribution. Now S, on the other hand, is a little bit different calculation. This is the standard deviation calculated as if instead we'd given it a set of sample data in the form of what we call grouped data. Let me give you an example. Let's just suppose that this was a random sample of 7-game playoffs of the data from a much larger population of 7-game playoff series, and we drew a random sample of 82 of those series, and that's the data that's shown here. And if we wanted to compute a standard deviation for that sample, then we would be using this value for standard deviation, S sub x. When it computes S sub x, it's basically just using a variation on the formula that you used for calculating standard deviation when you were given a set of sample data back when you were studying descriptive statistics. Okay, my point is this: with discrete probability distributions, you want to use sigma sub x for your standard deviation. Now, the fact that these two values are close in value is an artifact of the law of large numbers. As your sample size gets larger, as you know, the behavior and characteristics of the sample are going to approach those of the population from which it's drawn. In conclusion, this demonstration shows you how to compute the mean and standard deviation for a discrete probability distribution. Be sure, as I mentioned before, to take the time to do the calculation for the mean by hand first before you begin relying on the calculator to do it. The calculation for the standard deviation is one you should review carefully if you don't attempt to go through the steps yourself. But as always, doing it by hand will only help you to gain an understanding for how these formulas work.